It is a cold Saturday here in North Carolina, and while we could be out on the boat in that comfy enclosed cabin, the C-Dory, I've decided to kind of lay low today and try to knock out a couple to-do list items on the boat. Today I'd like to tackle a little electrical project, actually kind of a big electrical project. We'll be replacing and upgrading the house kind of battery wiring from the battery box in the back of the boat all the way to the forward electrical panel. But before we dive into the project video, I just wanted to take a quick second and thank everybody that's been watching the videos. Kind of started like a little C-Dory mini series, and I'm totally an amateur. I really have no idea what I'm doing. It's been fun making the videos, and I definitely enjoy taking you guys along for the ride. And I appreciate all the likes and the comments and just the positive feedback. If you wouldn't mind subscribing, liking the videos, sharing the videos, and hitting that little bell notification button up at the top of the videos, that would be really helpful. If there's any video ideas that you guys want to recommend, please feel free to drop them down in the comments, and I'll see if I can kind of touch on some of those topics, either C-Dory related, boat related, or whatever. Let me know. All right, it's a cold one out here today. So like I said, we're going to tackle some electrical issues that I've been having with the boat. Maybe not issues, but upgrades, and there's definitely some room for improvement. So first of all, this is my battery box and kind of like my battery switch circuit breaker area. It's a mess. It's pretty nasty. So you can see that circuit breaker there is broken. The reset lever thing is not even existent. The battery switch is okay, but it only has a off, one, or combine selector. And I want to swap that out for a battery switch that lets me run off of either battery independently. So when I'm staying the night at anchor, I can switch over to one battery while having another battery totally isolated for the morning. So if I need to crank up, if I kill the battery overnight or something, I'll have a fresh battery to kick off from. But one of the main issues I've been having, so the last overnight trip I did, I was running that diesel heater, and I noticed something kind of strange. So when let me see if I can show you here on the panel. So I keep the boat on. When I'm running the heater or any of the electrical accessories, I've noticed a big difference between the voltage shown on the engine instruments. That voltage comes basically right from the battery through a separate harness of the engine control harness. Notice a big difference. Right now we're like 12, a little over 12 volts there. And if we go, you see 12.2 volts on the Garmin. So the Garmin is powered by our house, I guess you'd call it like the house wiring circuit. So behind the console here, there's a breaker panel, and that's fed by a relatively small, it's like maybe a 12 gauge wire that goes from the battery switch. And so when I put a load on it, so for instance, let me kick on the freshwater pump here, you'll see that voltage drop considerably. So now it's dropping on the panel, but also if you look at this voltmeter here, we're at 11 volts. So 11 volts there, but we're still over 12 on the engine instruments. Same thing happens when I run the diesel heater. So when the diesel heater first fires up, it pulls about 13, 14 amps for maybe 4 minutes. And then once it's kicked off, it kicks down to like 2 or 3 amps, depending on what kind of heat setting you're on. So anyway, I did a little bit of troubleshooting. I put a voltmeter on the batteries in the back of the boat, and then measured the voltage at the house battery terminal panel up behind the console here, and found there's quite a bit of voltage drop just across the wire that runs from the battery switch all the way forward. So today we're going to replace that with a larger wire, but while we're at it, we're going to do a couple upgrades. We're going to replace that battery switch with a 4-position switch. So that gives us the ability to turn the batteries off, both of them on, or 1 or battery 2. So we'll have 4 different positions. We're also going to replace the house battery, house power circuit breaker back there with the new one. That one's kind of sketchy. In the future, I also have some plans to install a battery monitor. I'll probably place it here, a little display that'll show us power draw, like how much current we're pulling from the house batteries, voltage, and stuff like that. So let's get into it. All right, so we're climbing forward into the V-berth here. We're on the back side of the console. And I imagine most boats will have a pretty similar arrangement. Maybe not quite as easy to access as it is on this boat, but we're going to pop this little cover down. And now we've got full access to our electrical bird's nest up here. And if you can see, these bus bars are the main kind of distribution panel for all of our house battery activities. And then there's also a separate fuse panel here that was probably added. I don't know if that was factory option or somebody did that down the road. But both of these panels are fed by this wire right here, this one, and then there's a ground. Looks like it's peeling off over here. And they bundle together into this cable and run all the way back to the batteries. And that looks like, that might be like 12 or 10, that's probably 10 gauge wire. I wanted to upsize that. It's clear that we get a big voltage sag when we fire up the diesel heater. So I can see the lights here dim. When the diesel fuel pump is running, actually, I can see the lights flicker a little bit. And of course I can see the voltage drop on the Garmin display. So I know that we're losing voltage. And that simply means that we don't have enough wire capacity to transfer that much current from the batteries to this distribution panel where it goes out to things like the heater. And so we're going to upsize the wire. All right, we're back at the aft end of the boat again, and I just wanted to take a peek back into this little battery compartment and show you what I'm talking about. So this is our old battery switch, and this wire here, so this cable, this is what's feeding all of the house accessories. And so this cable, this positive, comes from the battery switch here through this busted up old circuit breaker that we're going to replace, and then through this cable here, this nice loomed cable, all the way forward to that panel. That's the thing we're going to go after today. Okay, so before we start tearing into the wiring, we're going to need to do a little bit of homework, some planning here. So disclaimer, do this at your own risk. Every boat's different. I have no idea what I'm doing, so don't listen to me. I am an engineer. Take all this with a grain of salt, but this is the best. I'm doing this to the best of my abilities. So, like I said, first thing we need to do is some homework. And so what I've done here is I've started a little spreadsheet on my computer to lay out some of the major loads. I say major. What I mean by that is we've got things like lighting. So all the lighting on the boat, I've already switched to LED. So that's going to be like, a few hundred milliamps worth of current draw. So we're just going to ignore that. But major loads would be things like the diesel heater, the water pump, the fresh water pump that I've put on the boat, the windshield wipers, actually, like probably kind of a reasonable load. And so categorize these by peak load and average load. And then I've summed all of these up essentially at the bottom here. So the total load peak is 23 amps. That's if we had the diesel heater warming up, the water pump full blast, and both windshield wipers on and pulling kind of their max rated current. Realistically, when the diesel heater is already warmed up, and then the more of a typical current draw for the windshield wipers, we'd be pulling closer to 8 amps. But I want to go ahead and try to size this system to handle kind of like anything we can throw at it. So let's go for the peak load, which is 23 amps. That's going to give us some headroom too, so if we add accessories, or should I say when we add accessories in the future, we'll have a little bit of headroom to grow into. So step number one, total up all your loads, go for peak, shoot big. If you install too much capacity, that's okay. What you don't want to do is you don't want to install too little capacity. All right, step number two is determining how far our wire run is going to be. So that's important to remember because the longer the wire, the larger diameter it's going to have to be in order to carry the amount of current that you need without suffering too much of a voltage drop. So all I've done here is just really simply, I've laid out a tape measure on the ground, and I'm measuring from where the battery box location is, which is the start of our wire run, approximately kind of midships, actually forward to that where the electrical panel is here. So that's where I'm starting the tape measure, and then it's going to end at the battery, and that total run length is about 15 feet. So, all right, we're back at the computer. I've just noted 15 feet as our wire run length. And then what I said, we're going to do some math. I lied. Why do math when you can use online calculators? I found this really cool calculator by Bay Marine Supply. I guess just throw that in Google, like Bay Marine wire size calculator, and it'll bring you to this sheet here. And there's a couple different inputs. So these are all things we've gathered already. So amps, that's how much current we're going to pull. So I put in 23 as our peak load, 23 amps. Length of the wire, it's going to be 15 feet. And then you throw in volts. I don't know why that's necessary because it calculates like percent drop, but we'll throw in 12 volts as kind of our nominal voltage. And then when you hit calculate, what you'll see is it spits out these values over here. And these are voltage drop based on wire size. And so if we start way down here at the bottom of the chart, this is the wire size and gauge. Gauge is a little confusing because the larger the number for wire gauge, the smaller the wire actually is. So 16 gauge wire is pretty small. When you go up to here to like 1 gauge wire, that's huge. And then we even have like 1/0, 2/0, 3/0, and 4/0. Those are massive cables. So I don't think you're going to see anything in the, the 1/0, 2/0 or bigger range in a boat the size of our C-Dory. Some of the main battery cables might be like 1 gauge, or they're probably more like 4 gauge. But anyway, over on the right here, they show this kind of color coding system. And so red, don't even think about it. That means you're going to have a voltage drop of more than 10% at that peak load. Yellow, it's like maybe you can get away with it, but not great. We're not doing anything janky on this boat, so we're going to avoid yellow. We're going to keep it in the green, which is 0 to 3%, excellent for most uses. Even 3%, in my opinion, is, I don't know, maybe more than I'd like to see. Again, it's always better to be conservative and install bigger stuff, knowing that you might add load in the future, than to undersize it. So if we go back to this column here, dropping down the list, and it looks like 10 gauge would give us about a 3% drop. Like I said, I'm not crazy about 3%. I'd like to do one better. So I'm going to go ahead and pick 8 gauge wire here, which is a 1.8 or 1.9% voltage drop. So that's very tolerable for the types of loads that we're going to run. So we're going to go with 8 gauge wire for this system. Just to show you kind of as a demonstration, if I were to bump this length up to, like, say, let's double it. Let's go to 30 feet. Now all of a sudden you see we're going to have to get down to like a 4 gauge wire for the same level of voltage drop. So it's very important that you factor in the length of the cable, because that's totally going to affect the diameter, the size of the cable that you're going to need. Now, the final step here, step number 3, is determining the ampacity of the wire. That's kind of a funky word, but really what that means is like how much current in amps can an 8 gauge wire support. And this is going to depend on a few factors, like is it a copper wire, how many strands are bundled together in the wire. There's even a spec for like if the wire's in an engine room or not. So I don't know if like there's some kind of like electromagnetic interference or something that plays into that equation that you experience in an engine room and not elsewhere. But because what we'll do is we'll go to this under the same Bay Marine Supply wire size calculator. Beneath the calculator portion we just used, if you scroll down, there's an ampacity limit chart. And so this is really cool. It's going to give you the gauge of the wire, AWG, American Wire Gauge. We're going to use the outside of engine spaces category for our evaluation, because this is not going in an engine compartment. And then we're going to find 8 gauge wire, which is right here. And if we go over to 8 gauge wire and we go to, we're going to run a 2 conductor wire, the ampacity is 56 amps. So that's a lot. And really what that's going to let us do is, A, we have to make sure that our total load is nowhere near the total ampacity or amp capacity of that 8 gauge wire. So we said it was 23 amps, so we're like half of that. That's great. Being conservative is good, remember. We have like a safety factor of about 2. But the other thing ampacity is going to let you do is it's going to let you size the size of the circuit breaker that you can use for this run. And so we always want to put a circuit breaker at the beginning of this run, so that if there is a short circuit between the battery and somewhere downstream in that cable setup, that breaker will trip and we won't start a fire. And so that breaker needs to be lower than the ampacity of the wire, just kind of a general rule of thumb. And so since that's 56 amps, we could go for like a 60 amp breaker. That may be what we do. Again, if we're kind of erring on the side of being conservative, erring on the side of caution, you might go with like a 40 amp breaker just to play it safe. And so you're guaranteed that that breaker is going to blow well before you reach any limits of the wire. And so that's what we're going to do. We're going to go for, I think, a 40 amp breaker for this setup. All right, so time warp here. The Amazon truck arrived, and voila, like magic, we've got all the parts we need for this project. Start here. This is the wire we're going to go with. This is 8 gauge. You can see it's pretty heavy stuff. 8 gauge, 2 conductor, stranded copper wire. So we're going to need a positive and negative, which is the 2 conductor part of it. Stranded means it's made of these really thin copper strands, if you can see in there. And that's important because it's going to make the wire a lot more flexible. And that's also a nice thing to have in kind of a dynamic application like a boat where, you know, as we're banging around offshore or whatever, and this wire moves over the life of the wire, it's not going to work back and forth and eventually break. So stranded wire is good for, you know, marine and automotive applications, or anywhere that you need like a lot of flex. I got this off of Amazon. I think I got like 25 or 20 feet of it. It was like $40. So good deal there. Next thing we have is the new battery switch. So this is a Blue Sea Systems 4-position battery switch. It's got some big giant fat lugs there. And then this is a 3-pole one. They do sell some that have a 4th pole. That is, I can't remember what the acronym for that is, but basically if you have a 4-pole one, it just means that you're able to switch to the off position while the engine's still running, without frying your charging system fuses. We don't have that. We've got a 3-pole. So it's very important that I remember never to turn this battery completely off and never disconnect the motor from the batteries while it's running. Next component, I've got this new waterproof circuit breaker. This one's a 20 amp, so I may or may not have gotten a little trigger happy and placed some orders on Amazon before doing the math we just did. But don't worry, I've got a 40 amp on the way, and I actually have a 60 amp on the shelf, which maybe I'll use for this video. But this just has 2 poles, and then it's got this little reset button and reset lever. So this is what's going to blow if we exceed the current capacity of the circuit for some reason. It's nice on boats to have a circuit breaker versus a fuse if you can, because if you don't have a spare 20 amp fuse in this case, all you have to do is fix the problem and then reset it on the water, so you won't have to have a spare fuse on hand. The last thing we got, some of these I've already had laying around and some of them I just bought, but we've got some ring terminals. These are crimp-on ring terminals made by Ancor. And these are marine grade, so they have heat shrink, if you can read that, jacket. So when you do crimp this onto the wire, you can hit that with a lighter or heat gun and shrink this around the wire just to kind of keep the connection a little more sealed up. I mean, it's not really going to seal it because water could get in from the other side probably, but anyway, that's just kind of like a marine standard style ring terminal. So those are the parts we need. Okay, so we're on the boat, and I think the first thing I'm going to start with my least favorite job first, which will be running this wire through the boat. So I'm not going to show a video of how I did that. I mean, it's pretty self-explanatory, but I'm going to start with the wire in this battery box here, and I'm going to run it forward underneath the gunnels. I don't know if you can see that on the camera, but there's the wire bundle, kind of the OEM wire bundle. So we're just going to run this cable in parallel with the standard wire bundle. Runs into the cabin of the boat through this like foam seal, if you can see that, under the galley counter, up under here next to the helm, and then it's going to land over here at our this mess over here. So I'm just going to fish that through the boat, and like I said, I'll save you the agony of watching me do that. All right, we're back. And because this is a C-Dory and everything is just incredibly easy to work on, especially the wiring, running that cable took all of like 3 minutes. So I still haven't zip tied it in place yet. So, you know, I'll have to come and kind of tighten everything up. But I'm going to wait until I get everything connected before I actually like zip tie anything in place. All right, so now that we've got this cable run to the forward circuit panel place, I'm going to start stripping this cable without hopefully cutting the cushion. There we go. And I'm going to just strip the red and the black conductor out of this thing. And then we're going to put on some ring terminals to attach it to the lugs on the panel. So I'm just going to, there you go. And that'll let us split this off and hit the positive rail and the negative rail. Oh, well, other way around. Positive rail, negative rail. There we go. We have 2 stripped ends now. All right, you'll notice a quick change in lighting. That's because I had to turn off the power to the cabin lights to make this happen. So obviously turn off the power from your battery before you start messing with this stuff, because you don't want to short these out. The power shut off. I'm going to install some of these ring terminals. And then we're going to use this crimper on the largest setting. Squash this guy down. All right, it's crimped. Give it a little test tug. Looks good. So now I'm just going to do the same thing to this end, and then we'll be able to screw these up to the terminal blocks on the breaker pin. All right, so we got our new cable run. I'm going to clean this up later, but for now I'm just going to let everything loose so I can get the lengths and everything ready as I pull this back through the boat. But I'll probably, zip tie this up like that or something like that, just tidy it up. But these are tied into the main terminals now, big heavy lugs. So these are our main power distribution rails tied into our big fat 8-gauge cable. So now we got to run back and do the same thing at the battery end. All right, next up, I'm just going to go ahead and I'm going to remove this old battery switch, disconnect all these battery connections, and I'm going to remove that circuit breaker. And we're going to yank this stuff out of here and swap in our new components. So that should be pretty straightforward. I'm also going to take the time to tidy up this battery compartment, kind of tuck some of the cables back there out of the way and clean this up a little bit so it's just, there's less clutter. All right, we're back. It's day 2. I ran out of daylight yesterday, and so I decided to call it quits for the night and pick it up today. So we're back at it. We've got the line run, and now I'm just kind of cleaning up some of the battery compartment stuff. So in here, you can see I've removed the old battery switch. I've installed our new 60 amp circuit breaker, and then I've put a new positive lead on it. So this is going to go to the kind of output side of our battery switch, along with this big fat engine cable here. Both of those will go to the positive output side of the battery switch. So that's the next step. All right, and so it's important to remember to put grease on all of your electrical connections. This is kind of like anti-corrosion. Was this antioxidant joint compound? I just got this at Home Depot. Put that on all your electrical connections to prevent corrosion. Electricity and salt water don't like each other. So now I'm going to make the connections to the output side of this battery switch. Okay. I couldn't show much of what was going on there because it was just a total wrestling match of wires, or with all these wires. So kind of hard to film, get the camera in there and my hands at the same time. But we've got all the connections in place. I've wired up battery 1. Let's see, battery 1, battery 2 to the switch, and then this is the input from the motor, or output, I guess you could say. And then this is the output line. Give you a quick recap of what I did while I was kind of wrestling with the wires in here. Sorry I couldn't film that because it was just too tight on space. I couldn't get the camera in here and kind of wrestle with these wires and get my hands in there at the same time. So we've got battery 1 connected on this left side of the battery switch. Battery 2 comes in at the bottom. That goes over to the port side of the boat. On kind of the 3 o'clock position over here, this is the motor output cable, I guess you could say, or input when the motor's charging. So that goes right to the engine. And then this smaller wire here is what comes off that same output lug, but goes through our circuit breaker into the input side of the circuit breaker. So always remember that these have a designated input and output side, so don't get those backwards. And then this line here, the smaller red cable, that runs to that cable that we ran forward to the front of the boat. So that's our house power. So things are way tidier in here now, way better in here now. I'm really happy with it. All right, so it's the moment of truth. I fired up the diesel heater here, and we are sitting at about 11.7 volts there, 12.2 here at this power meter. That's way better than it used to be. So we had about 12.3 volts before we turned the diesel heater on. We know that when the diesel heater first kicks on, it's in kind of warm-up mode. It pulls about 14 amps, which is kind of a lot of current when it's got to run the glow plugs and that kind of stuff. And before doing this wiring upgrade, our voltage would drop in that state down to like mid 10 volt range, which was like pretty bad on one, especially on one battery. Now we're sitting at like 12 volts, which is, like I said, without the diesel heater load, we were sitting at like 12.3. So huge improvement. That upgrade in wire size definitely made a big difference. So really happy with that. Way better, way smaller voltage drop. All right, guys, thanks for tuning in. Pretty pumped with how this project turned out. The before of the battery compartment, looking pretty messy, kind of nasty, and we've got that kind of totally sketchy circuit breaker that I wasn't too keen on, and the after now of what it looks like today. So way tidier, way cleaner, and hopefully more reliable. And on top of just cleaning things up and putting in some new components, we've got that heavier wiring now to support the added electrical loads that we put on the boat, and as well as any future loads. That made a huge difference. So really pleased with how that turned out from like a power supply standpoint. So if you like the video, please be sure to click the like button down below. And if you subscribe to the channel, I'd really appreciate it. So thanks for watching, and hope to see you on the water for our next adventure. Take care.